I would today especially welcome a few guests. Since we have APEX and Oracle Spatial, a combined topic today to talk about, we have invited a few of our colleagues from the APEX team, and Yassine gladly agreed on taking part over in the demonstration of specific features of APEX integrating spatial. And we also have Monica Godoy and Carsten Czarski from the APEX team in the panel. They will also watch out for any questions you have regarding, specifically regarding APEX. Okay, so as usual, we want to start the session with a few pieces of general information. The first one is you can find the recordings of previous sessions in the Ask Tom app. If you click on recordings there, you will find all past sessions in the Ask Tom series. And if you want to find specifically the sessions in the Oracle Spatial series, then just type in as technology Oracle Spatial, and then you will find the recordings of the previous sessions. Let me go to the next topic. So we are very interested in learning which topics are of interest to you. So please let us know if you want to have something specific covered in one of the next sessions. And if you have any technical questions, you can use these two public channels. So the one is Stack Overflow and the other one is Oracle Forums. We regularly monitor those channels if there are any questions regarding Oracle Spatial. And last but not least, I want to remind you of the TechCasts organized monthly by the A&D community, the Analytics and Data Oracle user community, and also the upcoming A&D Summit, which takes place mid-April in Redwood Shores. And if you have any questions, please use the Q&A box for those. I already said we have plenty of panel attendees to take care of your questions. Okay, so let's get started with today's topic, APEX and Oracle Spatial Unleashed. This is an ideal opportunity to acknowledge a colleague who has consistently championed native spatial features within APEX. And the colleague I'm talking about is Carsten Czarski. And again, welcome Carsten to our panel today and within the session. So just from my perspective, when I joined Oracle in 2007, Carsten was already widely recognized both inside and outside of the company as a leading database expert, especially for those fancy developer-centric capabilities like Oracle Text, XML, ODF Graph, and also Spatial, which we nowadays all together converge database features. And whenever there was a technical question to answer, SQL or a pure SQL problem to solve, or the best solution to find, Carsten was the go-to person, at least for me, but for plenty of other colleagues as well. And the APEX team was actually fortunate to bring him on board, and so was the Spatial and Graph team as well, since he continued driving native integration of spatial capabilities into APEX. Yeah, I think other people on this panel also agree with this, Hans. Maybe you can also
indeed,
say
yes. So also
words.
big thank you from the entire Spatial team, Carsten, for all the great work you've done. Championing the spatial technologies over the years. It's always been great to work with you, and we hope to continue doing that going forward.
Yeah, and since I do not know if everybody here in the audience is aware of Oracle Application Express, or short APEX, I just want to briefly let you know what APEX is about. So APEX is Oracle's solution for rapidly building secure and scalable enterprise applications, so both for the web and also for mobile devices. It is an integral part of the Oracle AI database, and it is developed by an agile and continuously growing team of developers, which is also tightly connected with the ever-growing APEX community or developer community worldwide. And a couple of those features, which I've here on the slides, like SQL Workshop, the application builder, you will see in the next couple of minutes with the demo parts we have prepared for you today. Monica, is there anything you would like to specifically mention about APEX, which I will not cover in the session?
Well, just one thing about that you have there in the name. The current name for APEX is Oracle APEX, right? The former name was Oracle Application Express. Of
Okay,
course,
good to know.
You can read more about APEX in our page, oracle.com/APEX, and more than the maps and all the things that you are going to see today, probably is going to be useful for you to know that we have, or we can cover workflows. Also, you can use data loading, you can integrate applications with DevOps. There are more than 10 applications, sample applications that you can find in the app gallery for you to start using APEX to see how you can create applications. So yeah, just the invitation to go to oracle.com/APEX and start building your applications with APEX. Thank you so much, Marie.
Thank you as well. So, and one of the applications, pre-built applications Monica just mentioned, which are available either via the application gallery or if you go to the GitHub repository that is maintained by the APEX team, which you can find the link here at the bottom of this slide. So there you can find plenty of pre-built applications or other reusable components such as plugins, for example. And the good thing about those pre-built applications and the reusable components is that they are, of course, obviously the reusable components, you can just grab and use those in your applications. But especially with the pre-built applications, you can just look under the hood and see how things are used, declared, and how everything put together is forming your application. And you can just copy and adapt certain features of those applications to meet your requirements and build new applications by reusing things that are already available. So we already talked about one of our best friends, which is who is Carsten. But when it comes to best friends of APEX, one of those best friends is JSON. The connection to the spatial team here is that there is a kind of extension to JSON, which is called GeoJSON. So including location information into JSON documents, and this is what you can see here as features. So this is a GeoJSON document consisting of geometry objects coming along with additional properties. And what we are going to show you is how you can use those GeoJSON documents, load them into your database, and then actually build maps from it in APEX. And the example I've prepared here is what I want to show you is just uploading GeoJSON documents in APEX, then creating an application and using the data set as a layer on an interactive map. And under the hood, it is what I'm going to show you right now. You use the SQL Workshop. There is this utility called Data Workshop. Then you can load the data, and APEX automatically detects the structure of the data and finds out that there is GeoJSON or geometry information included in the GeoJSON, and then the Data Workshop guides you through a dialogue where in the end you have the data uploaded into an Oracle database table with the GeoJSON document or the geometry from the GeoJSON document added as your geometry object. The specification for GeoJSON you can find on the internet, geojson.org. I will be showing how this can be done in a couple of minutes. Since I wanted to talk about the first and foremost component in APEX to be used with spatial data first, and this is a so-called map component. A map within APEX typically always consists of a background map, which gives you a guidance where you are, and geometry objects, or what we call layers. It can be one or more layers of spatial data, which are either sourced from a table in the Oracle database or external tables for that matter. And you can add those layers to your base map. The geometry objects, what you can add to your base map, are typically points, lines, polygons. So the simple features you already know that we can use or store as geometry in the Oracle database. You can also define those objects or geometries to be displayed as a heap map or as extruded polygons, meaning having third dimension included in the visualization. The underlying geometry object from the database can either be an geometry column, or it can be a varchar or a CLOP, and both varchar and CLOP then must contain the geometry information in the GeoJSON format. The other option beside the geometry column can be two numeric columns, which is valid for points, since points are typically represented by the X and Y coordinates, or longitude and latitude for that matter. And having those values in two numeric columns can also be used to visualize the data as layers on a map. Here on the right side, you just see that the data here is imported as a CLOP geometry object represented as GeoJSON. And what you can then see in APEX is having a first map with the GeoJSON data imported into a table, and then having the layer added as to the base map in APEX. And the way you do it is you define a region. I call it interactive map here on your page in APEX. This region is of type map, and the next step is, as I said, we have a base map and additional layers added to the map, and this is what you can then do underneath this interactive map region. You will find the layers, and here I've added one layer, the admin level 4 boundaries for Germany, so the county boundaries added as polygons to the map. And this is what I want to briefly show you. And let me go to my APEX instance for that purpose. So I've created a couple of applications, and I first want to show you how to, oh, no, sorry, I don't want to show you interactive map first, but what I wanted to start with is the utilities part and loading a data set. And here we have load data, and we can choose the file we want to add, and hopefully this stays as it was at the beginning. And what you can see here is that I have a GeoJSON file grabbed from my local file system. It is automatically parsed by APEX, and you can see here that this is the geometry column recognized, and let's give it a name. I think it was admin level, admin boundary, DE level 2. Quite a long name, but doesn't matter. Then let's load the data. And then we can just view the table here. So we have 16 states in Germany, and here you can see that there is this geometry column. And if you want to check the actual data, you can also see it here. So let me just increase the font a little bit so you can see it better. So the GeoJSON is that represents the actual, in this case, a polygon, was added as content to the geometry type. And now we want to add this data as a layer to our existing map. Now I'm going to add this layer to my interactive map, which already exists, and this is the one I've been talking about. So here we already have the layers for the counties, which is down here, and let us also add another layer, which is like I'll keep it short. Counties DE. It's not a points layer, it's a polygon layer. It's a database table which we use to query the data from. Then we have the geometry. I wanted to use GeoJSON here, and now just having primary key selected. And of course, I could now also choose color and everything else to make it nice and fancy, but let's keep it as it is. And what we can see here now is that we have another layer added to our map. So, and here you can just hide or display the new layer. And what you can also add then is giving additional information, such as what you want to see as info window, or when you hover over a geometry, which information should be displayed. So this is simply loading data and adding it as layer to your map. Are there any questions regarding the things we have seen so far?
There's nothing in the Q&A anyway.
Okay. Then let me continue with another nice feature. So what we have seen before is that every map consists of map background and layers plotted on top of the map. And sometimes there is a need for having a specific or a custom map background. And there are plenty of things we can use to shape this map background. And typical approaches for map backgrounds are either vector tile layers, so geometries put together and streamed as map background to your map. Raster XYZ tile layers as well, and what is called Open Geospatial Consortium Web Map Service, so a standardized way to represent maps as a service. And I want to briefly walk you through how you can define those different types of map backgrounds, and then we will also see one example. So those map backgrounds can be used in map regions or for display map, or with the feature of the geocoded address items. If there is a need to include, I'm sorry, there is, no, okay. So specifically for web map services used as map background, there are typically a couple of parameters, query parameters that need to be filled out when you define APEX supports us with automatically adding a few of those parameters in the definition. So you don't need to define those on yourself. And you will see what I mean by that a little later. So the intro part is there are shared components, and one of the shared components is for creating map backgrounds. And there you can see the three different types of map backgrounds: vector tile layer, raster tile layer, and OGC WMS. And there's also very nicely documented in APEX what everything is meant for. And let's just go through first defining a web map service. And here you can see the web map service already integrated as a base map in your application. And if you define the web map service, then typically the query parameters are like a bounding box, or you need to define the width and height. You also need to typically give the right request, which is then a get map request, and the format in which the result should be displayed. And very important information is the spatial reference system. All those parameters you can omit because they are automatically added by APEX. So which means that what you need to define is just the URL, the base URL for the service itself. It's a WMS service, the version for that service. Typically for WMS, you have 1.1.1 or 1.3.0. Then the layers for that service or that come along with those service and styling information. And here are a couple of examples I've included that you can use and try out on your own. And here is what I wanted to say for WMS, but here is the right place. Sometimes you need to provide API keys when using an external service. And for this, there is a placeholder API-key, which you need to include in the path of that WMS service. And let me just... So here we have the example with the OGC WMS service, the WMS URL, so the base URL and the additional parameters you need to define. You can give it the attribution and then just apply the changes. And the next step then is to use this base map. And let me again increase that one. And the way you do it is we have defined you have seen before that we have an interactive map, which is defined as a region. And if you go to the attributes of the region, you can find this map part there. And there you can take the background map from a shared component and you will find all the custom map backgrounds listed, and you can choose from this list which one you want to include. And additionally, you also have the controls that typically come along with navigating an interactive map, like the zoom and compass, where you want to position the navigation bar and rectangle zoom scale bar, all these things you typically know from interacting with map. The vector tile layer works similarly. It's under shared components. You define the URLs that actually define which data and the styles that are used by the data. And Oracle provides a couple of vector tile layers via the elocation.oracle.com service. And I've included here the URLs for the style JSON documents, and those you can use when defining the vector tile layer. And the way you do it is, again, what you've seen before. This time we select vector tile layer as type, give the URL, style sheet URL, and specifically for the elocation provided vector tile layers, you also need to give that header Oracle minus parameter you see here given with the value of Oracle Spatial. So this is how you define the map background as a vector tile layer. And then again, it is used similarly by having the map component and choosing from the shared components list the actual style JSON document. The last but not least is XYZ tile layers. And again, it works with URLs. You can see an example here. And maybe specific for XYZ is this notation of the zoom level, the Y and the X tiles, and the columns of those tiles. So this is specific to XY and Z layers to be used as base maps. And the example I wanted to show you is just, so let me go back to my applications, and here we can see the custom map backgrounds. And starting the application, you can see here that I have application where I can show the vector tile layers, XYZ tile layers, and what you see WMS. And here is the one for WMS, and just looking under the hood is what you have seen before. We have the map region here, and on the attributes, you can see here shared components. Then here is the list of already pre-built map backgrounds. And then let's go to the shared components. Sorry, that was too fast. And here we have a map background, all the list of map backgrounds, and let's create one. Let's call it USDA map background. And there is no API key. There it is of type Raster XYZ. And now I need to grab somehow the URL for that map background. So let me just briefly navigate to that page. Are there any questions?
Nothing in the queue.
Okay, so this is the URL I want to use, and then I create a map background. Nicely done. And then let's go back to my application. And here we have the raster XYZ tile layer based on this. Let's change this one using the new one, which is this one here. Save it. And now we have a different map background. So this is how you can define it and use it. Next topic. One of the important features is when it comes to visualizing data on maps, very often you have to deal with data that are not geocoded, meaning that they are not delivered as geometries or giving their longitude and latitude values or X and Y values. So you have a textual information about a location on Earth, which is typically an address or a point of interest. And the way to turn addresses into geocoordinates is called geocoding. And we introduced with the autonomous database as an in-database feature to geocode addresses using under the hood the elocation service, which we provide on this elocation.oracle.com. And the reference data we provide there are by the content provider here. And the way we use the reference data is by using the PSQL package SDO_GCDR. This package has a couple of functions and procedures which take either structured or unstructured textual information or address information and turn those into coordinates, or the way around is taking coordinates and retrieving the actual address from those coordinates. And this is done based on the reference data. So we are sending a request to the elocation service internally, and then it is either an address geocoded or the geocodes turned into address information. And this is something you can, out of the box, use within the autonomous database as a built-in feature. If you don't have an autonomous database, then you either have your own reference data set or you can use the elocation service by sending the request on your own. And this is why we made it easy to be consumed as part of the autonomous database. And the APEX team worked on leveraging this feature using the, let's say, database geocoding feature provided via this PSQL package and turned this into a native component, which can then be used in your applications in case that you have to deal with address information and you want to plot the actual locations for those addresses on your map. There is a Live Labs workshop, which we have created a while back, and there is a description of how you can geocode address information using the autonomous AI database. And there are just a couple of steps you can walk through, and you will finish in possibly less than 5 minutes to do that. So the first thing is that you need to have a database user which has the specific permissions. The required privilege to run the SDO geocoder package is provided using this call exec SDO_geocoder.elog access, and then you provide just the username. And once this is done, you can then connect as this user to a SQL worksheet and then call the geocoding function and retrieve the results of it. And this is what we will be showing in a minute. Just to finish or showcase an example of such a geocode request, you use this function here, and the result of that function is a JSON document which is given back and which contains all the information where, including the geolocation of that, the geocoded address, the X and Y coordinates of that address. And alongside the X and Y values, you also find more information in order to harmonize and or complete your address data set, like which municipality and or how accurate the match is. All those information you can find in the result set. And the result of such a query if you extract certain information using the JSON features of the Oracle database. Is just here extracting the longitude X and Y values and the match code and work with those. And within APEX, there is a pre-built component, a so-called process template component, which is called server-side geocoding. And this can be used to either geocode structured or unstructured address information. And the way it will be done is you use that process, you fill out the required parameters, and for either a structured address or an unstructured address, and then you get the result back and you store the result in a collection and the match vector item and the coordinate items, and those pieces you can then use in your application. And the way we will be doing it is what Yassine is going to showcase now.
Okay.
So let me
Thanks,
just
Karen.
stop here.
Yeah, so quickly share my screen first. Yeah, so basically you just saw with Karen how they can use the Geocoding API from using a call from SQL. But what I wanted to show is actually to put that in action in APEX. So basically, APEX wraps up that Geocoding API into a declarative process. So you don't need to write that SQL by yourself. So, and this process is available in many places in Oracle APEX. Yeah. So, and let's just see how we can configure it. Basically, this is the Oracle APEX page designer where we structure our page. There's the page structure, and in the process tab, we can see that we have our server-side geocoding process. And all we need to configure it is just specify whether we would want to provide it a structured address or an unstructured address. And for the structured address, we'd want to bind in the specify the items that holds the country, street, and so on, and also where to write the geocoded results. So that's being the first match coordinates, geocoordinates, which is returned in a GeoJSON format, and also the match vector. This can be used interpreted to evaluate how the exactness of the found geocoded match. So for each address attributes, we can the geocoder encodes in the vector matches how exactly each attribute is matched to geocoded data. Yeah. So with 0, that means that specific attribute is exactly matched, and so on. And we also can specify a collection, a big collection where we will have all the potential or candidate matches that geocoded found. Yeah, so we can quickly run this page and see that in action. So this selects, for instance, a structured address. We can provide the structured address, quickly geocode it. So as you can see, behind the scene, APEX does all the geocoding and calls the geocode API, parses the results, and you can see it's now displayed in the in this map, and we also have the resulted match vector. We can see so the house number actually is encoded in the fifth character. So 0 means the house number is exactly matched. Also, the 7th one, the character, we have also a 0, so means the street as well is matched, and so on. And the city it's the 11th character. So yeah, this is a very clear address, and we exactly get the exact match. So all the founded matches was one exact match that the geocoded found. Yeah, so that's good. But if you're familiar with APEX or have used it before, you might know that we've had for some time another the geocoded address item. So it does similarly basically the same thing, but it's much more interactive, and this is mainly designed for the UI. So we can specify an address, and we will have this autocomplete provided with all the matched result that the user can then select. As you can see, and so basically for the server side geocoding, where it shines is where in place where we would need to geocoding with independently from the UI, so where there is no user interaction. So think about, for instance, if we have some table of legacy data with just postal code that we would want to geocode and do all sorts of into geocoding to do all sorts of the spatial analysis, or maybe if we have an example of an order system which extract where we extract all the postal addresses and we manage the delivery in our APEX app. So then we would need to geocode all those postal codes into concrete geocoordinate that we can then display in the map into all sorts of spatial analysis on. So, and I have a simplified scenario for that for the later case. So here I have a scenario of this is a table of orders or deliver orders where we have in a real scenario we might get this from an external services as a nightly import of a CSV from an external ordering service from an ERP, for instance. So, and then we manage the delivery in dispatching all the orders from APEX in an APEX app. So we would want to do a batch geocoding for all the postal addresses. So in this case, it's just try to run the geocoding. To run all the geocoding, I'm using an APEX. Let's keep it running in the background. So what I'm actually using at the head is I'm using a declarative component of APEX automation, which basically runs a job on the background. So it could be either an on-demand or a scheduled job and basically how it works is we provide a query of a data source where, and basically we would it will provide for a source the data from our table which are newly inserted from the external service, which are not yet geocoded, and for each row it will run a specific action in APEX automation, which would do similarly as I've showed in the page designer. We have a server-side geocoding action. We can just map all the address source and where to write the results, and that's basically it. You can see that the batch geocoding was executed successfully, and we got all the addresses geocoded into geocoordinates into a GeoJSON format, as you can see. So that's basically it, and we could do then all sorts of spatial analysis on. We could have it represented in a heat map to determine the areas where we get most orders, or maybe to determine the warehouses from which we would dispatch specific order, and so on. So basically that's it, and you can also see that for almost all the addresses, they are correctly geocoded, and with just some exceptions, some of them are. So if the postal address is not specific enough, or it's missing a straight number or a house number or street name and so on, or if it's totally random and invalid, then depending on the business criteria would need actually, and how exactness would need that geocoded to be. So in this case, I'm taking it a bit further, and so for those ambiguous addresses or which would require, for instance, a human in the loop to verify those addresses, I'm so for the automation starts a workflow, an APEX workflow. It's basically another another declarative component in APEX. So for each exception, exception that we encounter, we would branch. We have a workflow for that would branch and determine if it's ambiguous. Then we would assign it as a task for just the logistics staff to review and approve. If it's invalid or the street, for instance, for the delivery street, exactly the street number and the house number are actually important. So we would need that to be a valid address. So in that case, I'm just marking it as rejected. But in a real scenario, we would actually send this or request the customer to provide a valid one. So as you can see, we have in we have the workflow instances that were executed in in this page. You can see the status of the workflows for the specific exception we encountered. So for this one, so this is an ambiguous address. So the geocoded found multiple potential matches that we would want the human to select the correct one and approve that. So for that, I would navigate to and log in as a logistic staff or manager, and then we can see that we have all this the ambiguous addresses assigned to us for review. We can check all the we can see here the address and customer name and the status, which is ambiguous, with a list of the potential potential geocoded address. So this is where the logistic staff would verify which one is correct, select the correct one, and just approve. Yeah, we can do the same for the other ambiguous addresses as well. Select the correct one, and this one is just rejected. This then would in a real scenario would be directed to a customer to provide a valid one. And just back to the app. Now we can see that all the addresses are verified. Some of them are rejected, and the ones that we manually verified are marked as verified. And that's basically it. With that, I pretty much concluded my demo.
Okay, so I wanted to say how nice the things come together. The workflow feature in APEX, the automation feature together with the geocoding feature. So very nice. Thank you very much, Yasin. If somebody asks for having a look at your sample application, can they reach out to you, or is it available as a private application, or will it be available?
It's not yet available as sample app, but they can reach out to me through my email, and I'm happy to share the app for sure.
Thank you very much. We have one more last topic to show technically, and this we covered Denise, so I will hand over to Denise for the next part.
Okay, great. I'll try to be quick. Okay, can everyone see my screen?
Yep.
Okay, great. So I'm going to show how to embed a published Spatial Studio project in an APEX app. And just quickly, I'm going to go over the steps. So we're going to start in Spatial Studio. We're going to ensure that all of the data sets that we need are public, and the project is both public and published. And I'll show you all of this in Spatial, so we'll go through it. We're going to we're going to note our IP address and project ID as we generate our URL and create an access token. And we're going to need all that information, which we'll put into a script that we'll use. And then I'll go into APEX and we'll do a couple things in there, which I'll show you. One thing to note is we're going to insert into the project something called required jet. That's currently not in the documentation, but we're working with our doc writer to update that. If your map isn't displayed, you can close your browser and restart it using these bypass parameters to bypass the missing HTTP certifications. That's an issue for you. And if you can note that down at the bottom of the screen, that might help you out as well. So I'm not going to go through the slides just in the interest of time. I'm just going to jump right into Spatial Studio. So I'm already in Spatial Studio. I have this project here. If you've done any of our live labs, it should be pretty familiar to you. This is just our Intro to Spatial Studio data set. And what I would do is come into here and save our project, to save it as a project and then have a name for it. And I would publish the project using this button under Actions, and I would hit Share. So that will share the project that will allow us to share the project with people. So I would close out of here, and I can see that now our project is under our Publish Projects tab. And the other thing I want to do is go into data sets and ensure all of our data sets that are in use are public. Excuse me. And to do that, if they weren't already public, I would come in here using the ellipse and go to Permissions and just click this public button. I've already done all this, so I don't need to go through it, but I know that I'm going to use these data sets, so I want to ensure that they're all public here. So I'm going to go back to my published project and create that URL that we're going to need. So I'm going to go to URL, and I can either take these off or put them on. It doesn't matter for what we're doing, but what I'm looking for is this information here. So I need the IP address of our Spatial Studio, and I need this project ID. And this is going to be important for the script that we're going to build. So we will put that IP address here. And the port is going to be 4040. And you want to make sure that you're using the HTTPS version of it, not the HTTP version. So it's always going to be 4040 as your script, unless, of course, you've changed your port to something else, but the default is 4040. We'll put our IP address and port again here under the server URL. And then that project ID is that project ID that we had noted when we created our URL. And then we need to create a token. So to create the token, we close this and we go to console and click this Access Tokens button. And I've, of course, already created my tokens for this project, but we're going to create a token here. So we give it a name, and we want to make it valid for a certain number of minutes. So the default is, of course, 120, but you can go up to 9,999 minutes. So that's the biggest token that we can create at the moment. And you can decide whether or not this is read only or read write, depending on your security and your resource types. For this, we would just need embedded published projects. And of course, it shuts off the allowed action. Okay, so this is going to create a token. I didn't give it a name, so I can't do that. So let's just do test just to show you what that looks like. And you copy that token, and as it notes here, it's not going to be displayed again. So you want to ensure that you do save this. So that information goes into our script under this spot here. Okay, so now we've done everything that we need to do in Spatial Studio. I'm going to go over to APEX. And so in APEX, I, of course, already have a application built, and I'm in my application. On the page that your project is going to be embedded in my case, it's just my home page. In the topmost part under this page 1 home, you need to come down here to, where is it?
It's further up. It's further up. You have already passed it.
Sorry, did I scroll too quickly?
Yeah, you can type in JavaScript in the filter.
There it is. Yep,
there it is.
I was trying to go too quickly. So under your JavaScript subheading over here under your page settings, you need to put require jet in brackets under file URLs, and you want to save that. And that's just required to run your embedded project. Of course, I've already created a page button here, but to drop in your embedded project, we would create a new region, and then you would drop in static content into our body. So we would just put this right here into our body to create the content that we would need for this project. And the only other thing that you would need to do to run this is drop that script that we put the information into in this HTML code under source. So we would have our little static content type and put this source. So we can see that here, this thing that we showed you in the PowerPoint presentation. And then I would be able to save this and run it. And it gives us our embedded map from Spatial Studio. So I can use my little zoom in and out and pan around and see everything. I had only had these layers active in my project before I published it. So these are the ones that I can see here. But if I wanted to come back into Spatial Studio and update what's published here, I can make those changes. And you can see that it's the same project here that we can see in Spatial Studio. I think the other probably the most important thing to say is that what I just went through is available in our documentation under 7.4, embedding a public project in an APEX application. And I'm going to drop that link into chat so everybody can see it. And again, we are missing one step in the documentation here that I'm working with the DocWriter to update. So hopefully in the next couple of days, that required JET information will be there. I don't see any questions. Corinne, I'm going to stop sharing and allow you to finish up.
Yep, just one last thing to show. So let me just briefly share my screen again. Thank you very much, Denise. If there are any questions regarding this part, yeah, just let us know. A little more steps than the other things which we've explained, but totally doable and nice since you can use Spatial Studio to prepare everything, load your data sets if needed from different sources, not just GeoJSON, put everything into the database, do some analytics, and then put it together as a project, which you can then also publish in APEX. Just to let you know where you can find more information, here are a couple of links you can use. And then I just wanted to make you aware of our next Ask Tom session. It's always the last Tuesday of a month. And this time, if you have any
I have a quick question before we finally shut down. A quick question to Denise about functionality of Spatial Studio available in Oracle APEX if you do the embedding. That was a question which just popped up in the Q&A.
Any functionality? So let's go back. Can I share my screen? Yeah, so that's great. There's a little bit less functionality available in APEX. So we can do a couple of things, right? So we can highlight a section, you can pan around, you can you can do some measuring and make a polygon. But yeah, it's not as robust as it is in Spatial Studio. We don't have custom regions, or I don't think we have search capability, but we do have measurement and creating a polygon. We can play with our drawing tool as well. So it's pretty robust. I think the biggest thing that Spatial Studio has is, of course, you can do analysis and add data sets and do the changes of like the background images and change the colors and stuff. So but you just anything that is in this area of the map you can see, but anything that is in the back end. So for example, yesterday Corinne had asked why I didn't have my zoom functionality shown in APEX, and it was because I had not turned it on yet in Spatial Studio. So I needed to turn it on in my Spatial Studio instance and then republish my. Hope that answers the question.
Then thanks again, Denise and Yassine, and also Monica and Carsten. Thanks everybody from the Spatial team, and we hopefully see you again in 4 weeks from now.